Hello class, Professor Anderson here. Thanks for coming by today. We're going to talk about some of the kinematic equations problems that you guys have been looking at. And let's take a look at a very specific one first. Let's toss a rock up in the air and have it fall down into a hole that we are standing next to. So here's our picture. We're standing here next to this hole. We have a rock. We're going to toss it up in the air, and it's going to go up and then come back down and fall into this hole. And let's give you a little bit of information here. Let's say that we toss the rock up initially at 25 meters per second. Now, is that a realistic number? Can you throw something at 25 meters per second? What do you guys think? You can? Okay, how fast is that in miles per hour, roughly? 50 miles per hour. 50 miles per hour, yeah, you can probably throw it 50 miles per hour. That's maybe a little harder straight up, but certainly a pitcher, a baseball pitcher, can pitch up to 100 miles per hour. So being able to throw it 50 miles per hour seems reasonable. Okay, let's also say that this height right here, h, is 10 meters. Okay, so we're going to throw this rock up, we're going to let it fall down into the hole, and let's ask the following question. What is that final speed? When it hits the bottom of the hole, how fast is it going? And let's take a guess. What do you guys think? Is VF going to be bigger than VI?
Yes.
VF seems like it would certainly be bigger than VI. At least the magnitude. Let's not worry about the signs yet. We'll say that the speed is certainly going to be bigger. Okay? Is it going to be a lot bigger or just a little bit bigger? Well, we're not really sure. 25 meters per second seems like it's going to go pretty high compared to how far it falls. So maybe it's not going to pick up that much speed on the way down. We'll try it out and see. All right, what do we do next? What do you guys think? We got our picture. We have some givens here. What should our next step be?
Pick an equation.
Pick an equation. What sort of equations do we want to look at? Kinematic equations. So let's go to the kinematic equations, and let's see if one of those will help us. So what is a kinematic equation? Somebody shout one out. How about this one? Y final equals, do you guys remember the rest of this? Y initial plus Vy initial times time plus 1/2 Ay t squared. Okay, we're in the vertical domain here, so we'll use y's for all this. So let's take a look at this equation and see what we know and what we don't know. Do we know y final? Yeah, I think so. Y final is right there. Okay. Do we know y initial? Yeah, that's where we started from. Do we know Vy initial? Yes, 25 meters per second. Do we know t? Don't really know t yet. Do we know a sub y? Yes. Do we know t here? No. But it looks like maybe we have enough. But if we're trying to find v final, this isn't really going to help us, is it? This doesn't have v final in it. All right, let's go to a different equation. What's another equation that you guys have?
Velocity final squared.
Velocity final squared equals velocity initial squared plus 2 a sub y yf minus yi. Okay, that looks like a good equation. Why is that a good equation? Because this is what we want. This we're given. This we know. This we know. So in fact, we know everything in that equation except VF. Seems like we should be able to solve it for VF. So let's try. Okay, so we're going to start with this equation right here. We're going to see if we can solve this thing for VF. Obviously, we can. But let's think about what these numbers are. we certainly have VI. We said that was 25 meters per second. What is A sub y? What is the acceleration due to gravity? Minus g. Negative 9.8 meters per second squared. What about y final? What is y final going to be? Negative 10. And if y final is negative 10, what is y initial? 0. Okay, and so this whole thing simplifies quite a bit. Vi squared, we have minus 2g y sub f. And then we're going to take the square root of that whole thing to calculate v sub f. All right, let's punch in some numbers and see what we get. We've got 25 meters per second squared. If we're in SI units, we don't have to write down the units every time. We've got minus 2 times g, which we said was 9.8 meters per second squared. And then we have y final, which we said was negative 10. So we set the origin at ground level, and that means that the bottom of the hole is minus 10. And that's good because the minuses are going to cancel out there. All right, 25 squared is 625. We are now going to add 20 times 9.8. And if you guys plug that into your calculator, what do you get? 28.7 meters per second. And are we done?
Yeah, that's it.
Can we say this is our final answer?
It's going down.
Okay. Velocity has a direction associated with it. So if positive y is up, then this thing at the bottom of the hole is clearly going down, and so we need a negative sign right there. Okay, so this is the final velocity of the rock at the bottom of the hole. The speed is a little bit bigger than 25 meters per second, like we guessed, and it's not that much bigger, so it seems to be in the right ballpark. Okay? Hopefully that is clear. If that's not clear, come see me in office hours. Cheers.
Thank you.